Okay, so good evening and welcome back to the session. So, friends, in previous session we were going through with uh, the different types of job roles what we are having inside the GenAI, or different job roles or different tasks that we can perform inside the GenAI. So the we have gone through with that particular aspect. And we have seen like prompt engineering is one stuff, then RAG is there, fine tuning is there, then pre-training is there. And from the difficulty perspective as well, we have seen the prompt engineering is very easy to learn, and that is having the less difficulty level. Once we are talking about the RAG, so that is having the medium difficulty level. Fine tuning and pre-training, these are somehow towards the higher difficulty side, and it requires huge amount of resources as well. Okay. And least number of organizations are working on to the fine tuning and pre-training piece. Let me try to show you certain diagrams. I'm having this particular diagram for you. Uh, Guys, are you able to hear me? Am I audible?
Yes, sir.
Yes, sir. Yes,
Screen
sir.
is also visible.
Okay, okay, perfect. Okay, so I was talking about the the diagrams, like what are the different diagrams that we can have. So over here, this is the piece for the pre-training, where what we are able to see. So there are the huge, you can say, text corpus, or the data captured from internet, Wikipedia, and different sources. And then we are going to train this particular data. On top of that, like, we are going to perform the training, and then we will be having, say, untrained LLM. Then we will be going to, say, perform the pre-training and all. Then we will be having pre-trained LLM. And then like, this particular LLM can be utilized in order to ask the queries. So in the third phase, step number one, train, then step two is the pre-train, then step three is user is asking the queries to this pre-trained model, and inside the step four, the LLM is going to provide the output. So what we are able to get from the pre-training phase, that is the foundation model or base model. Over here, the accuracy of that particular model is not up to the mark, and we have seen it in our previous session. We have gone through in detail like what exactly is being happening inside the pre-training. Okay. And why the accuracy is low over here. So in order to improve the accuracy, what we are having the fine tuning phase. So fine tuning is nothing but you can say, let me open a notepad. Okay. And let me save it as well. And this will be, say, session 4. So I was talking about the the pre-training, and it is providing me the foundation model and base model, and the accuracy over here is not up to the mark. Now what I need to do, I need to perform the fine tuning. Okay. Fine tuning is something that is looking like this. So what we are doing over here, we are having certain raw text data, and what we are doing over here, we are giving it to the pre-trained model. And then there is a custom knowledge base based upon what we are going to do this particular fine tuning, and we will be getting the fine tuned LLM. Okay. So you can take it in this particular way. This is something, say, uh, reinforcement learning. Okay, let me mention over here. Uh, Reinforcement learning. So reinforcement learning through human feedback. And it is known as RLHF. Okay, so fine tuning, what we have seen, like based upon the custom knowledge. Okay, we are going to do the fine tuning. It is something like we are using a knowledge base in order to provide, in order to, you can say, train large language model, do the further optimization onto the base models or foundation model, so that it will be able to answer the queries in a proper way. There are multiple techniques for the fine tuning. You can take it in this particular way, like say PEFT, parameter efficient fine tuning, and full fine tuning. Okay, so these particular things, although like we have discussed in our previous session, but let me provide you certain insight. So after this particular fine tuning, what we can have, we can embed this RLHF piece uh, in order to do the further refinement onto the large language model. Okay, so and this is the same stuff, like we will be asking certain questions to the large language model along and providing the answers. So based upon the question and answer, the LLM will be able to train itself in order to provide the better output. You are like over here feedback. So it is something, say, uh, if the LLM is not providing the proper output, you are providing the feedback, like this particular outcome is not correct. And I used to give an example. Say if the two friends are there and they are willing to pluck the mangoes from the tree. So this is the mango season as well, and they are having stone in their hand. So one friend is guiding to the another one, like you need to hit the mango. So the person throw the stone towards the mango, and if it is going above from the mango, then the friend will say you need to decrease the power. So that is nothing but a feedback is given. So in the same fashion, like over here, if the LLM is not working properly, the users are providing the feedback, the human is providing the feedback onto the output, and that is known as RLHF, human reinforcement learning through human feedback. So this is perfectly fine, but once like we are moving in our journey, then we are able to hear of what LLM agents. Okay, LLM agents. Okay, can anybody tell me like what do you have you heard about LLM agent? Nikhil, Vikas, what do you understand with LLM agent? Daksh, Vipin.
Yes, sir.
Like similar like API, like you told
Yes,
enough in the
sir.
first session.
Mm-hmm. API, okay. But what is the exact functionality over here? API can be anything.
Like to access the big data, like this big LLMs models.
You're moving in a right direction to
Like
access the data. Okay, that is perfectly fine. What else?
Sir, can I say something?
Sure.
So LLM agents means like we want to like output based on LLM functionality. Output will be based on LLM agents. Output will be we are going in a direction. Output will be through autonomous process. Like
Mm-hmm.
agents are working with the autonomous process. They are taking the decisions based on no human intervention.
Mm-hmm.
That is the that is like LLM is working like a without LLM is working like a supervised manner
Mm-hmm.
with no human intervention is required. Like they are working with the autonomously.
Hmm. But why we need to have, the question is this, why we need to have this?
Like
So
to give prompt,
so
to
so
give prompt, and then LLM understand that.
Okay, okay, let me explain you in a simpler way. Okay, so prompt engineering, then RAG, then uh, uh, fine tuning,
Sir, actually, LLM
and
agents are required because sometimes LLM is not having the proper knowledge of any subject. Like they having some cutoff date, kind of.
mm-hmm.
They are not trained properly. So in this scenario, we are creating the agents and giving the like required information in terms of documents, in terms of files. With the help of we are creating the agents and with the help of proper information uh, we are doing some automation or we are doing some projects where LLM are not up to date.
That's correct, and that's correct. So, let me explain it in a more simpler way, or let me simplify whatever you have mentioned. So, friends, we have seen this particular flow, like say prompt engineering, RAG, fine tuning, pre-training. These are the like the tasks what we use to perform, or with the help of the large language model. Like prompt engineering in order to get the output, RAG that we are augmented certain documents in order to get the correct output. Fine tuning is something like we are tuning the weights of the large language model, and pre training is nothing but collecting all the data, whatever is available, and then do the training, and we will be getting the foundation model or base model. Okay, so over here, these particular steps, pre-training and fine-tuning, these are nothing but providing certain large language models. Fine-tuning, you will is providing you the fine-tuned model, and pre-training is providing the base model. Let me mention over here. So, what I can say, optimized model, which is given by fine tuning, and the pre-training is giving me the base model. Okay, so base model is having the ambiguities inside its output. Okay, the output will not be fully correct once we are having a pre-trained model or base model. Now, say we have done the fine tuning and we got the optimized model, that is perfectly fine. Okay, but the motto what I'm trying to say over here is the fine tuning and pre-training. These are the the costly phases. Okay, a lot of cost is involved over here. A lot of computation power is required in order to perform these two activity. We know it very well, correct? Are you with me?
Yes,
Ashok,
yes.
Mm-hmm.
Yes, sir.
yeah, we are with you, but having the just smaller query here,
Mm-hmm.
like you said, we use the base model having the some ambiguities and some issues. After that, we can optimize the model. On the same model we modified, or we can go for the other model.
No, base model is
Like, for
utilized in order
example,
to.
here question answer we can say, okay, for
Mm-hmm.
this model having the some issues.
Mm-hmm.
Okay. So after on the same model we optimized, or after that we can change the name or things what we can do here happening inside this.
Yeah. We are going to change the name post or like
Okay.
doing the optimization or post fine tuning a particular model. Let me try to show you something. Okay.
Mhm.
So Hugging Face, this is the repository basically of the different models. And if I say GPT, okay. So over here, like GPT, this is the base model basically, yeah. Okay, and GPT-Q Pro and A3B, GPT-Q and Chat GPT. Okay, so that is something like the fine-tuned model. GPT is the
Okay.
base model, and on top of that,
Mhm.
like we are having different models, right?
Mhm. Mhm.
So we are going to change the name based upon our, you can say, task that we are going to perform with respect to that particular large language model. You know, large language model is trained on a huge amount of data. It can do a lot of things, but probably it is fine tuned on a very specific data.
Okay.
Correct. So
Mhm.
that will be the default functionality for that. Although like it can do the different task as well. We have seen it in past. Correct.
Correct.
Yeah. So
Okay.
a large language model can perform a lot of tasks, but there are certain default activities for what it is meant, okay, or it is designed. So or you can say on top of those particular activity, it has been fine tuned. So we are going to change the name, or that
Mhm.
is, you can say, the another version of that
Okay.
particular large language model. We used to do the versioning inside the software. Like if we are having version A, then we post like performing certain tasks, we will be having the version B. Okay. Okay.
Okay.
So
Understood.
this is this is the normal process, and it is applicable to all the domains. It is not limited to the software one. If you are
Mhm.
talking about the telecom, like say, uh, we are
Yeah.
having
Software
certain
versioning with.
release. Yeah.
Mhm.
Yep. So that is the case. Let
Mhm.
me come back onto the point.
Thank you.
So okay, so we were discussing say fine tuning and pre-training. We can't do it on daily basis. Okay, so we we can't do it onto the daily basis because the cost is involved over here. Correct. So what we can do at this particular moment, or you can take it into the different way. Uh, say if I'm having a particular large language model, and say let me take the example of say GPT-3. Okay, so GPT-3, it was trained onto say 2024 data. Okay, it was trained in 2024, and the latest version which is available is for say 2024, based upon the October 2024. Let me take an example specifically. So we are having it for 2024. Now if we are going to ask a particular question based upon the current situation, and say if we are asking like what is the current situation in Iran, okay, can you tell me something about Iran and US war? Okay, so at that moment it will not be able to provide the information because it is not trained on to that particular data. The event what we are asking, it was not there during the pre-training or during the fine-tuning phase. So how to get the answer for such activities or for the data where the LLM is not having any information? What I need to do at that moment? Hmm, what you can do if the LLM is not having the information about the event? What you can do?
We can do firstly we can go for drag and
Ah.
Second option is
But
LLM
but
agents. Yeah.
RAG is very specific to a particular organization or a society or a domain. What I can say, domain is the broader term. Basically, it is limited to specific documents, and the information we need to keep on, like we need to keep updating that information in those particular documents. So that is another challenge with respect to the RAG. So what we can do over here, friends, we can have the LLM agent. LLM agent, what it can do, it is having say tools. LLM is having tools basically, and say one tool is there, say Tavily search. Tavily search. So, or you can say simple internet search, or Google search. So, say if someone has asked a particular question, then if the LLM is not having the information, it will go to the LLM agent, and LLM agent will use a particular tool in order to provide that particular answer. So it will fetch the current information from the internet, and based upon that, like it can mold the output and provide the outcome, and that will be more correct, right? It will fetch the current information from the internet. No, at this moment we are not, you can say, stick to a particular RAG mechanism, or we are not having the dependency or the documents updated inside the RAG knowledge base and all. Do we need to insert more documents and all? So that particular piece will be gone. Let me simplify it. So don't like, probably Daksh and Vipin will not be able to understand the RAG and all at this moment, because they are not having the context. So the simple answer is, the LLMs are trained onto the onto a particular data that is not the current one. Basically, there is a certain cut of date. Now, if we are willing to get the answer for the current situations, then what we need to do, we need to connect something like a LLM agent, which is going to do the search onto the internet and provide you the more accurate information. Making sense? Is it fine with everyone?
Yes, sir.
Daksh, Vipin?
Yes, sir. Yes, sir.
Okay, perfect. So you got the information about LLM agents. Now, there is another term that I want to discuss: few short learning. Few short learning. Now, if you are not having, now, like once we are going to do the fine tuning, so what we used to do, we like ask question and answer, say provide the question and answer related information that I have mentioned in the previous session as well. So it was something like this: say, what is your name? My name is Ashok. What is GenAI? So I will pass these particular question and answer to the large language model, and these are thousands of questions. Now, during let me mention, during the fine tuning phase, we pass 100K of the good quality uh, questions and answers to LLM in order to optimize, in order to optimize it. But and I have mentioned that these particular tasks are done by the specialized organizations. Like you are going to do this fine tuning stuff. There are specialized organizations inside the market which are going to perform these particular tasks. But if you are not having hundred of k the good quality question, then what you need to do? Okay, so at that moment that the few short learning will come into the picture, and it is something like this only. Okay, but what is being happening over here, uh, it will be at this moment it will be uh, 10 to 100 questions only in order to train the LLM to provide the answer, to provide the correct answer. Okay, so this is something like, say, if you are not having thousands k or 100k of the questions which are required in order to do the fine tuning, so what should you do? So there is a solution that is known as the few short learning, where we are passing 10 to 100 questions only, and these are the same and these are given into the same fashion what we are providing inside the fine tuning phase. So we are passing only a few questions to the large language model in order to boost the performance. So this is nothing but the few short learning. Correct? Is it fine? Few short learning.
Yes.
Okay. So like we have gone through with the basic terminologies what we are having uh, inside the GenAI from the starting perspective. Now over here, say onto this particular website, Hugging Face. So onto the Hugging Face, let me, you can create on huggingface.co, and post logging in, you will be able to see these particular models and all. Let me log in over here and say Llama model. Okay, so just have a look over here. Llama 3.18 billion, Llama 3 8 billion instruct, Llama 3.2 3 billion instruct. Okay, so Llama 3.2 1 billion instruct, uh, 1 3b is deciding, that is denoting the total number of parameters. How this particular number is coming, so we will be going to have the detailed discussion on top of that particular piece. Okay, so we are having different models. Say this is Llama, we are having GPT, and say GPT-3. Okay, over here, if you are able to see GPT 3.5 Turbo, GPT 3.5 Turbo 16K, and are you probably this is for the medical activities. Okay, GPT-3 Medium and GPT-3 Core Small based on GPT-2, GPT-3 Finnish Small. So probably it is working onto the Finnish language. So we are having the different large language models. And over here, GPT-3 summary, GPT-3 quality filter. I can essay with GPT-3. So a lot of, you can say, models are there, and if you are able to see the total count over here, so at this moment almost say 2.8 million models are there onto this particular website. Okay, so 2.8 million models are available, and now the main stuff like how to use this particular model, the main point, how to use this particular model, how to use these models, LLMs basically. So there are basically two ways, okay, use these models. Okay, first way is download the model and do the inference. Okay, number two, call the LLM using the API keys and do the inference on the remote machine. Okay, so these are the two basic options with the help of like we will be going to do the inference on top of the large language models what we are having now. What I have mentioned, there are certain tasks and there are certain default models which are created in order to perform that particular task, and we will be going to discuss, we will be going to see those particular things in detail, but from our course module perspective, like I will walk you through download a particular large language model on your machine and then do the inference, and this particular piece we will be going to see, say, uh, download default model or LLM basically. Okay, download default model. You are going, you are not going to specify the model over here. There is not any requirement to specify the model, the LLM name. You just perform the task and the default model will be downloaded. We will see it in today's session only. Then download LLM by specifying its name. Okay, so we will see. And uh, from the API perspective, we will be using OpenAI models, LLMs basically, OpenAI LLMs APIs in order to do the inference. Okay, we will see. I will like provide you the detailed information how the OpenAI large language models are utilized through the API. Yeah, we will see those particular things practically. There will not be any issue. So uh, let's proceed with this particular example. Today we are going to proceed with very simple example, and before moving further with respect to a particular example, let me try to show you something. Say GPT, and let me open GPT, this one, and over here if you are able to see, so inference provider, and this is doing what, image text to text. So if there is a certain image text, so it is going to convert it into the text basically, and in order to do the inference, what it is providing, say, use this particular model, and we are having the different ways to use this particular model. So first one is given the transformer. You know, like the large language models what we are going to use, these are based, these are working onto the transformer architecture. And over here the transformer library what you are able to see over here, with the help of this we will be going to download these particular model on our machine, and then uh, do the simple task. It will not be a very, you can say, difficult one. You will be able to understand. We just like write down 4 to 5 lines of code and we will be able to use the transformers. And if I click onto this transformer, so it is providing this piece of code. And it is like mentioned over here, it is mentioned say from transformer import pipeline, then we have mentioned the pipe. Okay. And then loading the model and all. So we will see like how we can use the transformer library in order to do the inference with respect to the large language model. So this is based upon say how to use this particular model. We will be going through with using the Google Colab. Kaggle I haven't used yet, but like I will try to show you if you are willing to go through with the Kaggle. This is similar to the Google Colab only. It is going to provide you the certain environment and where you can write down your code and do the execution of your code. More or less these are the same things. There will not be difference. So we will be going through with the Google Colab, writing down the code over there and do the inference on top of our data. Okay, we are not going through with these local lab stuff. This is not required at this moment. Okay, so what I will do, I will go over here and I will create a folder for you and say new folder. Item doesn't exist. So what I want, I'm going to create new folder and say GenAI, say batch 3. Okay. So over here, what I will do, I will create a simple Python 3.10 sheet and I will give a name, say first program. Just give me a minute. I need to take a call. Okay, so we are having this particular sheet. This is generative AI first program, and what we are going to do, like this will be the simple program, and what we are going to do over here, uh, we are trying to do the sentiment analysis. To mention over here, sentiment analysis. Analysis with transformer library. Yeah. So in order to do this particular stuff, what I will do, so over here, say use this particular model and transformer, and I will copy this particular line. Say from transformer import pipeline. Okay, so I'm going to import pipeline, and pipeline is having all the models and all information. You will see. So I have imported this particular pipeline from the transformer. Basically, I'm going to utilize the transformer library, and from transformer, I'm going to import the pipeline. Okay, so it is going to import it. It is taking too much time.
I think so. Go to Google Colab. It will work immediately.
But let me do it over here. This is required as well.
Acha, so okay, in between having the small query,
Mhm.
so you said like transformer, it's a library, and
Yeah.
inside the pipeline we are having the models, correct? So
Hmm.
the the model is available inside transformer, not, or I'm little doubt here because
So, pipeline is once just have a look onto this particular line. Okay, say classifier. Classifier. I'm going to set it and say pipeline, and then what I can do, sentiment analysis. So, what do you think? Where the models are existing, in pipeline or
Can I say?
in
Can I answer this
in
question?
transformer? Yeah, yeah, you can.
Actually, because actually thing is like that. LLM is possible, or generative AI is possible due to its transformer architecture only, or and GPU, graphic processing unit. So transformer in transformer architecture, all the like all the calculation is going on with the help of attention mechanism and MLP. So in attention mechanism, tokens are talking to each other, then they enrich the last token. And in MLP, we will get the external information. Our LLMs get the external information. So transformer is the basically brain of LLM or generative AI.
so my question is inside this no model is
No,
available.
uh, no,
Transformer
no,
is
no,
architecture is available in LLM only.
guys, just wait. So don't try to mimic it with respect to the transformer architecture. This is a library, and in this particular library, we are having pipeline, which is nothing but the combination of the different large language models. Correct. There are certain inbuilt large language models which are tagged to this particular pipeline.
Okay.
It is not like your transfer market architecture. They have given this particular name. It is a somehow you can say framework related stuff. We will be using LangGraph and LangChain. We can use Llama Index as well. Okay, so is that not a transformer architecture where like we will be having the LLMs over there?
Mhm.
So uh, uh, can I say it, this is not that is not on to based of transformer? Yes, that is based on the transformer architecture, but over here this is just a framework. At this moment, this is a framework which
Okay.
is carrying the functionality how to work with large language models. Don't
Mhm.
try to mimic it with the transformer architecture. What
Mhm.
Hello, sir. Voice not coming.
am I audible? Hello, hello.
Yes, sir.
Am
Sir,
I
no.
audible?
Audible, but
But
voice was cracking.
it's internet issue, I think.
Let me remove this.
Okay. Are you able to hear me?
Yes,
Yes,
yes.
now better.
Okay, perfect. So, guys, transformer over here is a framework based upon what we are going to learn the large language models functionality. And what they have given a pipeline inside the transformer library, which is the carrying different large language models. I have not passed a particular large language model over here. No model was supplied default defaulted to Distilbert based base uncased fine tune SST to English and revision. This particular model has been picked up. Okay, and just try to focus on to this particular line. Download the model and do the inference and download default LLM. So I haven't. This is not any requirement. There is not any requirement to specify the LLM name. So we haven't specified the name of large language model over here. But once I'm mentioning this sentiment analysis, this pipeline is smart enough in order to pass the default model in order to perform a particular task. And default model for sentiment analysis is Distilbert base uncased fine tune SST to English. Making sense? Are you able to get?
Okay, so it is also a framework like LangChain and LangGraph. We are calling the model to provide the inference.
Hmm, that's it. And if we are using LangGraph over here, LangChain over here, is that a transformer architecture? Yes, behind the scene, like we will be working on to the LLMs only, but with transformer library, with LangChain, with LangGraph, it is providing a an environment basically where we can write down the code in order to get the outcome, do the inference on top of our LLMs. Fine. Are you able to get?
Fine, sir.
Perfect. Okay, so we are having this particular pipeline, and we are having a classifier. So what I want to do, I just want to do the sentiment analysis. I haven't specified a model, so it has picked the default model. We will be in tomorrow's session. We will be passing another model in order to perform the same task. But at this moment, we are moving with the default functionality. This is the default model for the large language model for the sentiment analysis. And over here, using a pipeline without specifying a model and reversion into the production, not the recommended. So over here it is saying, say, if we are passing without a specified model, so it might be possible like you have done the testing onto the different model, and in production it can call to the different model, so that is not recommended. So recommended piece is you need to specify a particular large language model name, what you are going to utilize. So that we will see. And as this particular machine is onto CPU, so LLM requires GPU, but we are not having GPU, so the device set to CPU basically. Yeah, this is perfectly fine. We have just written 2 lines of code. Now what I will do, I will say mention, say I just want to review what I want to review, and I can pass something. Say I watched a movie and I don't like it all. Okay, so I just want to do the sentiment analysis based upon this particular sentence. And what I will do, I will say have result, and I will pass this particular review message from this particular classifier, which is having this particular large language model. And then what I will do, I will print the result basically. Yeah. Okay. And it is saying, say, the sentiment is negative over here, and the score is 84%. So it is able to get the insight. This LLM Distilbert based uncased fine-tuned SST2. So this is fine-tuned model basically, I think, because you were asking. So the name Distilbert was the initial, Distilbert base was the initial model, and the name has been changed with respect to the English language, and this is the fine-tuned model which has been picked in order to perform the sentiment analysis. And this is the default model. We haven't specified the name over here, and it has picked the Distilbert based on cased fine-tune SST2. Okay, I can have the different example as well, say review 1, and GenAI is looking promising for telecom domain. Okay, so I'm having this particular review 1. This is another sentence, and I will pass this review 1 from here, and then I can print the, okay, so let me take it result 1, and I can print the result 1. Okay, so it is saying negative. Okay, so it is saying GenAI is looking promising to the telecom domain. So it is, now just have a look over here. For me, it is a positive, you can say, sentence, right? But the outcome which is given by this particular Distilbert based on case, it is negative. So probably I need to do this particular, I need to utilize the different LLM, because this is not providing me the correct output. Right? We can face this particular challenge. Or I just need to do some more fine tuning.
So you can type 5G is booming technology nowadays. Then it will provide positive response.
5G is going.
5G is booming. Booming technology nowadays.
Nowadays. Okay. The main intent what I want to show over here, like how to use the transformer library in order to do the inference. Okay, then result 2, I will be passing the review 2, and I can say print this review 2, sorry, result 2. and just have a look over here. So label is positive and score is 99.7%. It is quite, you can say, good score. Correct. Okay. So what did you get from today's session?
Mm.
Mm-hmm. Vipin.
Sir, one query like this label and score. So we are giving one prompt. It is like no, you are giving one prompt. GenAI is looking promising for telco domain, right?
Mm-hmm.
So if it is coming negative and the score is less, then we have to tune it na. The same statement we have to tune in multiple ways, like to make it as a positive label.
Hmm.
Am I right or not?
Yeah, we need to tune it, but over here these are very, you can say, basic model.
Yeah, very basic model, but
These are very basic model, and probably these are not having that much of training. So, and the parameter size. Let me try to check this particular LLM. Uh,
Sir, as
I
per
have.
my understanding, we are checking the sentiment of given sentence with the help of this model. So if
Hmm.
sentiment is positive, then output will be positive. If sentiment is negative, then output will
No,
be
no, no,
negative.
no, no,
Label is nothing but output.
no. The thing is that over here, like whatever we are mentioning, it might be positive or negative. Okay, but how the LLM is going to treat it? That is the main thing. So LLM is treating this positive sentence in a negative way. That means there is something with respect to the training, right?
Yes, sir, correct. So
Probably.
LLM is also checking based on the correctness of the sentence. If sentence is like correct, then maybe it will give high score. If sentence is like not correct, or if we are checking something, it will give negative something. As per my understanding, sir.
Okay, so not an issue. The main thing over here is you are passing something and you are expecting a correct result. Try to think in this particular way. You are providing a positive sentence, and at this moment, you are having the knowledge that, yeah, this is the positive one. Okay, and you are expecting the same result from the LLM. So if it that is fine, you can say it is behaving good. But if the output is not correct from the LLM, that means it is hallucinating. It is providing wrong information. So there might be many issues. So probably the parameter size of this particular LLM is less. So over here, if you are able to see, this particular model is having 67 million parameters. But the LLM, say GPT-3, we are having 175 billion parameter in that model. So definitely the accuracy will be more over there. We are having the LLMs which are having, say, 1 trillion parameter. So we will see, like in our upcoming sessions, you will be having the better clarity. But the main thing over here is, say, if the LLM is not providing the correct output, it is it doesn't mean like, say, the the question is not, you can say, a question is correct. It doesn't mean the question is correct. Okay, it means like the LLM is inferring that particular question into the different way. The inference is done based upon its knowledge base, and over here the knowledge base is a 67 million parameter, which is quite less from the other, you can say, models. So we probably need to do pre-training, oh sorry, fine tuning, or uh, we just need to utilize the different models. Correct? Making sense? Any doubt, any confusion, anything that you want to ask?
No, sir, it's fine, sir.
Okay. Vipin,
So yes, not getting right now, but I think I will.
Not getting.
Yeah, okay, I think
So
no issue. I will like look later also.
okay,
Maybe,
okay.
maybe.
Try to go through with the
Yeah,
recording.
yes, yes. I will
You
come
will
again.
be able to get.
Right. Yes.
So we have just we have just gone through with the simple example where we are trying to do the sentiment analysis based upon a large language model now. And large language model is providing the outcome based upon its knowledge. Okay, so it might be correct, it might be the hallucinating piece may come into the picture, huh? So if the hallucination is there, outcome is not correct, it means we need to do the fine tuning and all. That is the difficult path. Another way, if you are having the access to another model, you can try to change the model and check the accuracy. Okay, we will see. We will start from this particular example only, and we'll try to use different LLM, and we'll see like what that particular LLM is providing in on top of that particular line. Okay, so I
Okay, sir.
think that's it for this particular session. Let me stop recording.